Hello everyone, this is Dr. Khalid, and today we will talk about the naming of organic compounds. And this lecture is basically giving you an overview of most of the organic compounds and different functional groups. From the previous lecture, you got the idea that what are the organic compounds, what are the functional groups, and what are the different classes of organic compounds on the basis of their function groups. So now, in this lecture, we will see that how we can name the organic compounds. So, in this particular lecture, we will generally overview the all of the classes of the organic compounds, but in during this course, we will exclusively discuss in details the hydrocarbons, and then there will be the more practice, and there will be more problems where a practice task for you that you will talk about, and we will discuss, and you will know in more detail about the hydrocarbons. The naming of organic compounds is basically we know that everything around us has a particular identity, and they are named for the identification, communication, and characteristics. So, in when we move from one country to another one, there are the different languages, and if you are not familiar, so this is difficult for you to communicate with other person who is native to that one. There are some of the terms, scientific and especially in the sciences, and in other subjects too. But I'm just mainly talking about the sciences. There are the standardized and there are the technical terms which are familiar internationally and globally. And then there is no gap, and there is no reluctance, and there is no hesitation to communicate with that one, because we all do understand what that exactly means. So if I say glucose here, and if a person in another country, so they know what the glucose mean is, what the Android technology means is, because these are the universally established terms. As we discussed and we know, there are more than 15 million organic compounds which has so far developed and discovered. Um, so Imagine if you have to memorize all of these organic compounds name. Oh, oh my God, that is totally um, impossible, and this is not for the human possibility. It means when we have the number of data, so there is the thing that we have to standardize that one. So there was a need that the chemists and the scientists come across, and they develop a standardized or systematic way to name the organic compounds, so they can communicate scientifically. So that's why through that systematic name, if I say the name of any organic compounds here, and I'm expecting someone in another country, another student, so if I'm just asking that question, so he or she is able to draw the right structure, because there is a systematic name, there are this is under certain rule. And if he or she is familiar with the systematic naming pattern and the practices, so he or she can easily draw that one. So that's where the internationally the sciences is connecting. So that's where we say that the science is bringing the peace, science is bringing the people together, because there is no language barrier when you communicating scientifically. You have the common things where you can communicate, though there is certain limitations for the normal conversation where you need the language, and English is one of that universal language where most of the people are following that, and you can communicate that easily. In the similar pattern, there was the method which was developed for naming of organic compounds. So for your information, I want to mention that there are the two kind of naming of organic compounds. Though the only systematic method is the IUPAC. So the one kind of naming is the systematic, which is the IUPAC naming, and the other one is the common or a trivial name. So the common and trivial name are basically which are from the sources when the compounds were discovered initially, because of their characteristic properties. They resemble with something and they were derived from the Latin or Greek words. So they were named in that way. So some of the common names are still popular and they are still in use. And because they were uh, well known, they were widely um, um, used, they were widely using, the people were widely using in their market and in their communication. So there are the certain common names which has accepted by the IUPAC, and we will discuss and we will explore some these kinds of the names. But the systematic name is basically, this is following the rule. So if you are writing the proper IUPAC name, so there is no nothing missing. So it means that there is no chance for any kind of misunderstanding and error in the structure if I'm expecting you to draw the structure. So from the IUPAC name, you can have the clear idea that what is that kind organic compound. So what are the different parts of this one, how this is linked, and how this is joined through the different atoms. So this is giving you the complete information. So we are mainly focusing on the IUPAC. So I have written the example here. So the systematic name, IUPAC name, uh, examples are ethanoic acid. This is one of the compound where there are the two carbon present, and this is having the acid as a major function group. And the second example is the ethyl alcohol. So this again, eth is used for the two carbon. I will show in the next slide that they are the certain carbon chains, and they are the certain parent names which you have to pick for by looking at the carbon numbers. So ethyl is for the two. So eth, ethanoic is again acid is of the two carbon chain, and the ethyl alcohol is again of the two carbon chain. But the difference is this one, when I'm saying this is ethyl alcohol, so alcohol means that there is the hydroxyl group which is as a major functional group. So now if you just look at the common name of these two examples, so ethanoic acid is famous and this is widely used, and its common name is as famous as the ethanoic acid and commonly used as an acetic acid. So maybe in our, and mostly in our teaching lab, we hardly say this ethanoic acid, but ethanoic acid is basically to confirm the structure and the chemical nature of your compound, but otherwise we use acetic acid preferably. And the ethanol is the common name of the ethyl alcohol. So these are the some of the common names which are still popular and which are still in use. So acetic acid is basically derived from the acetum, the Latin word for the vinegar. And you know, the acetic acid is basically the vinegar which you are using in a kitchen. So this is just giving you the idea that what is the reason, or what could be the possible um, source for the common name. So this is not under certain pattern or under certain rules. So this is just a random naming. The IUPAC name of an organic compound is basically composed of the three part. So this is just like that when you usually a name has a first name and then there is a last name, and some people have the middle name, right? So the organic compound's name is basically having the three parts. So one is the prefix, and then there is the parent, and the third is the suffix one. So I will elaborate to give you the idea what the prefix is giving you the information. So prefix is basically giving you the information about the substitution. Substitution means that there is a parent carbon chain. We know the organic compounds are mainly based on the carbon hydrogen skeleton. And then if there are some of the branches or the some of the groups are attached as embedded, you can just example that some of our people have the skin tag. So this is just a tag or the extra branch on that main carbon chain skeleton. And we know the tree has a main bark stem, and there are some small branches, so which is spreading that one. So this is the giving to you the information about the substitution, their position, right? And how many substitutions are there. So we will practice, so that will be easy, more clear to you. So the parent is basically give you the information, and that will be decided by looking at the compound structure, that how many total carbons are there. So what is the length of the main carbon chain means that how many carbon numbers are present there. So that is giving you the parent name. Now the suffix is basically the end. This is just like the last name. So it is basically named according to the major functional group. So in other way, the compound name having the three-part prefix, parent, fix. So structurally, from the compound, you have to see what is the carbon number, what is the length of the carbon chain. Now, how many substitutions are attached and at what positions they are attached on the main carbon skeleton. Now, the suffix is that is there any major functional group? So then you will name it according to the major functional group, because that is giving you the idea that either that is acid, either that is alcohol, or either that is just a hydrocarbon. So just we are stopping at this slide because this is important that you get familiar with the IUPAC. So IUPAC is basically a union, or you can say an organization, which has standardize these chemistry nomenclature. So IUPAC stands for International Union of Pure and Applied Chemistry. So this is just the monogram of the IUPAC. And you can visit that website. You have the very interesting stuff there. They have some activities they have, and recently they have launched the IUPAC periodic table challenge. So if a student is interesting, so you can explore these one. So now the IUPAC, initially IUPAC was just looking on the standardization of the atomic weights, the physical constants, and the nomenclature of an organic compound. So that was basically established in 1919 by the chemists from industry and academia, who recognize the need for international standardization in chemistry. But with the passage of time, as it grown up, so IUPAC has more domains to monitor, and that include the editing table of properties of matter, establishing a commission for the review of work, standardization of the formats of publications, measures required to prevent repetition of the same papers. So, you know, that when we say that we measure the length in the meter and the centimeters, and we measure the time in seconds and hours, and then we uh, have this unit for the volume. So they are the standard units for each of these properties, and these so these are also monitored. These are also standardized by the IUPAC. Now, moving towards the IUPAC naming. So IUPAC naming means that this is a systematic name. This is and this is following the rules which had devised by the IUPAC, that how you can name the organic compound as the proper complete name. So there are the four key steps in naming organic compounds, and that you have to practice. And this is just a one time if you just get that concept. So this is not that there is any change in these basic four rules in hydrocarbons or acid or anything. So these are the same for all kind of organic functional groups and the classes of compounds. So the only difference will be that what is actually the suffix you are using for the functional group. Otherwise, these are basic rules which you have to look for naming the organic compounds. So the very first thing is that you have to see in the organic compound the longest carbon chain and name this as an alkane. This is the parent name, right? So right now I'm not going into the other functional group. So because the very first thing is that you get familiar with what the carbon chain, what is the longest carbon chain means is. So we are going with the very basic thing, which is the hydrocarbon, and this is the alkane. One of the subclass of the hydrocarbon is the alkane, where the carbon is having the maximum number of hydrogen, and this is singly bonded with the hydrogens, right? So then you will name it as an alkene. So we will practice this one. So by the number of carbons, they are the different parent name, and you just have to memorize these one, and then your life is easy and you can name any organic compound, right? So if there is the only one carbon present and this basic skeleton is only the one carbon base, so alkane name will be methane, right? So this ene is a suffix which is basically giving it information that this compound is from the hydrocarbon, and this is from the class alkane, where there is only the carbon which is singly bonded through the covalent bond to the hydrogen. There is no double or triple bond, there is no hydroxyl, there is no chlorine, there is no other atom. So this is only the carbon hydrogen base, and the carbon is attached with the hydrogen through the single bonds. So if there is a two carbons, then you will use the ethane, right? If there is a three carbon, then you will name it as a propane, then the four butane, five is a pentane, and if there are a number of carbons are six, hexane, if the seven is heptane, eight octane, nine is nonane, and the 10 is decane. So though they are up to the 20, we can, the majorly, like they are the rare structures that go beyond the 20 carbons. So then there are the polymers, and that is another area how we can name these compounds. But for the basic structures, we are, for this course, we are just limitizing ourselves to the carbon chains which is up to the 10 carbon, and then we'll practice that how we can name the organic compound. So the first rule is that you have to select the longest carbon chain, and one important thing is that the longest carbon chain means that which is the continuous longest chain, so there shouldn't be any break, right? So for example, this is the structure. So if you just look at this one, this is if you just count the carbon numbers, and there is no break here, right? So this is continuously, you can start from the one end, and this is continuously, there is the line. Either you can draw straight, but we prefer to draw it in Higgs, in upward and downward position, because this is giving you the clear idea that there is a carbon and there is a carbon, right? So though I have write its open structure, where I'm mentioning that there is a carbon, there is a two hydrogen, but we can draw it in other way. But that is our next topic in further lectures, right? So if you just look at this structure, so you have to count the carbon, and then you can match that what would be the name of the alkane, right? So if we look at this structure, so this is a one carbon, second carbon, two, three, and there is a four. So it means there is a total four carbon, and this is making a chain of the four carbon, right? And this is the basic skeleton of this organic compound. So if we look at the table, so there is for the four carbon, we will use the but, right? And now we have seen that there is no other major functionality. So this is simply the carbon hydrogen, and each carbon is in a single bond with the hydrogen. So the carbon is attached with this carbon to the single bond, with this carbon to the single bond, and then there is the two hydrogens with each carbon. Well, you can draw it in a more open form, because at the beginning, if we just can go for it, so this is just like, I will just write the one carbon to just give you the idea that how it is. So this is somehow the condensed form structure of this one. So I have write in that way. So this is the condensed formula of this one. So you can shorten this one. Otherwise, if you want to for your understanding that you are not missing any bond, or you are fulfilling the carbon tetravalency, so then you can write in that open way, but you have to draw that hydrogen also here, right? So this carbon is attached with the three hydrogen, means this is singly attached with each hydrogen, and then there is an other bond with the this next carbon, right? So now we go for the next point, and that is that after recognizing or after identifying the longest carbon chain, you will see and identify the major functional group, right? Now if there is a major functional group, another functional group is attached, it is not simply the hydrocarbon, it is not simply the alkane, then you will replace the ane, which was at the end, as if you just look at this slide. So this was the ane, right? So methane. So we will just remove this ane, because now we will name it according to the functional group. So let's see, there is an example. It is again the 4-carbon chain skeleton, right? It means there will be the bute as a parent name, right? Butane. So firstly, initially we can say this is a butane if we just ignore that hydroxyl one, right? So this is the bute, and now we will see that there is the hydroxyl OH, which is the major functional group, right? And if you just check out the previous lecture, and there was a table where the functional groups were written, and their class name and their suffix was mentioned, so you can easily identify that what is that major functional group, right? So if hydroxyl OH is present, so this is basically the alcohol. So this is the alcohol class, and this is a major functional group, and the suffix we will use is enol, right? And we are basically removing the ane with, and we are replacing it with the anol, right? So this is enol. So I will write it as a butanol, right? Because but is for the 4-carbon chain skeleton, and then their ol is for this OH, which is hydroxyl, and this is mentioning the alcohol class. Make sense, right? Now the next point is, so you can just check out this table, and this table is basically for the major functional group. Do remember this, and just put your attention here that this is a major functional group, right? Where we have the some of the substitutions which are the minor functional group. So major functional group means with whenever you see these functionalities in an organic compound, so that will be added it as a suffix. So you will name it this parent on the base of the carbon chain, and this functionality as a suffix. Now the next is, the third point is, number the atoms in the main chain, begin at the end near the major functional group. It means that wherever there is a functional group, so you will start numbering from that side. So if you just look at this example, this is a carbon chain, which is of the 4-carbon numbers, right? And there is a hydroxyl group which is attached. So this hydroxyl, we have already discussed that this is basically the alcohol class, and we will use the suffix ol for this. Now this is a thing that for the organic compounds complete information, we have to mention that where that functional group is present and what is the substitution. So we have to give the complete idea. So far, so we have talked about the parent name, which is the information for the carbon chain length, And we have talked about the suffix, which is giving you the idea for the major functional group. Now we are moving towards the third part of the compound's name, that was the prefix, which we already discussed in our second slide of this lecture. So this prefix needs that we have to assign the number to see at what position that functionality is attached, right? So then we can name that one. And if there is no other substitution, then simply we need the suffix, and just the prefix will give you only the numerical value for the position. But if there is another substitution, then we will add that substitution, that minor functional group, as a prefix. So we'll see some of the examples there. So now if you count this one, this is the 4 carbon, then again you will go the but, then OH, and we have to start numbering from this side where this is near to the functional group. Why? Because we give the priority to this functional group, that we assign the lowest number to the major or the minor functionality on the organic chain. So if so our main focus is a major functional group, so we always go for the priority to the major functional group. So that's why we will start numbering from the side which is nearer to the major functional group. Now this is the one of the example where there is a major functional group, hydroxyl. So what would be the name of this one? So we can go for, this is again the but, right? And this is the parent part, right? And butanol, ANOL, ol, right? So this is the suffix part, ol. This is giving you the information, and butane is basically giving you the information about the 4 carbon chain. Now, for the suffix, what we need to do is that we have to mention that where that hydroxyl is attached on this carbon skeleton. So here this is attached at the 2nd carbon. So we will write 2 as a numerical, then there is the dash on and the bar here, and then this is the butanol. So that is the complete IUPAC name of this compound. So if I just write the name, so there shouldn't be any problem for you to draw its complete and the right structure. Now another challenge is this, that what else if we don't have the major functional group, but this is a kind of branching structure, means there is the continuous, if we just look at this one, this is the continuous chain length, right? Though this is also a continuous chain, but this is a shorter one. If you just count this continuous chain, this is of the 3 carbon. But if you just count this continuous chain, this side, so this is making the 4 carbon chain. And so the first rule was that we have to identify the longest carbon chain, right? So the longest carbon chain is of the 4 carbon. So it means that methyl will be treated as a substituent, right? So this is the minor functionality, you can say, or this is just a substituent, and this is a branch on this one, right? So I'm just writing the shorter one. So that substitute means that is a substituent. So now if you just name that one, so again, this is the but, but here we know that there is no major functionality. This is simply the hydrocarbon and the alkane. So we will write it as ane, right? This is a butane. But if I just write the butane, so this will give you the idea that this is just the 4 carbon longest chain structure. So you are not able to identify that there is any methyl group which is attached to this one, right? So I have to give the complete information to you. Is if I write the 2, and there will be the methyl, methyl is for, as we name the methane for the 1 carbon chain. So this is the methyl. I just write in a very short space. So this is methyl, right? So this is a methyl butane, right? So there will be bar between that one. So substitution, numerical value for the position, bar, methyl as a substitution, then the bar, and there is a butane, and butane is basically for the parent chain, right? Now the fourth group, fourth rule is this one, that once you have identified the longest chain, you have identified the major functional group, then you are numbering from the side where there is the major functional group is attached. The fourth thing is, if there are the substitutions which are other than the major functional group, they could be the minor functional group, or they're just the methyl or the alkyl group which is attached on this main carbon chain. So then you have to number these substitutions, and you have to name these substitutions, that what are exactly these substitutions are and at what positions they are. So in some cases, this is happening that there is only the one substitution. So if you just look at this example, so this is an example where there is only the one substitution, there is only the one methyl group is attached. So we will just name it as the 2-methyl butane simply. And what if I just cross this hydrogen, right? And I am adding another group here. This is the OH, right? So I have attached hydroxyl here. So this is a new compound. So how we will name it then? So it means you have to identify again the longest chain, which is again the 4-carbon chain. There is no increase in the carbon chain because this is the hydroxyl, which is not the part of the carbon chain, right? This is a heteroatom other than the carbon, so that we don't include and count in the carbon chain. So then this hydroxyl is there and this methyl is there on the same carbon, which is a carbon 2. So how we will name that one? So firstly, we can just write the parent, which is the bute, right, for the carbon longest chain, which is this one, right? And then we will see that there is the 2 position where there is a methyl, and there are the second carbon where there is a hydroxyl, but we can't write only the 2 hydroxyl but butane. We can't write only the 2 methyl but, right? So that is not enough. This is not giving us the information because we are not sure about the other substitution position. So we have to repeat the position if it is attached on the same carbon. If it is on a different carbon, then definitely you will mention the different position. That could be the 2 3 carbon where there are the 2 different positions. So you have to write the number according to the substitution. So in this particular example, the substituent is attached on the same carbon. So we don't have to go for the different numbers of the carbon. So what we will write here is that we will go for we have to decide now if they are the 2 different substituents, then we will go for their alphabetic order. So hydroxy will come on priority alphabetically on the methyl because H comes uh, first, then the M in the alphabetically. So this is the 2 hydroxy, right? And hydroxy we will use because now this is the minor functionality, so we will use its prefix. If that is used, sorry, I'm just not going for the right way. Let's see, right? So if there are the 2 functionality in that way, that the hydroxy and methyl is there, and then there is a major functional group, then we will add and we'll compare and we'll write these substitution on the alphabetic order. But in this particular example, the major functionality is the hydroxyl one, right? So we will write it in a way that we will mention this as 2 methyl, right? Because methyl is the minor functionality, methyl, methyl, right? And then the but, and then butane 2, again to mention that this hydroxyl is at this position. So this is the 2-methyl butane 2-ol, or otherwise you can write it in a way that this is a 2-methyl. So these both are acceptable. One is more detailed, and otherwise a little bit the simpler one. So this is a 2-methyl and 2-butanol, right? So this is giving you the information that the both substitutions are on the carbon. The major functional group is attached on the second carbon, and the methyl is on the second carbon. So we will never start the numbering from this side, because if we start the numbering from this side, so this is farther from this side, and in that ways the substitutions and the major function group will get the higher number. So we always will go and start from numbering from that side where we can assign the substitutions and the major functional group at the lowest possible number. Now the next is the function group priority order. So we will talking about the major function group, and this is the thing that you should keep in your mind whenever you are naming and you are identifying the functional group, that there is certain priority order. So carboxylic acid is the on the highest priority among all of the function group. So if there is a compound where is the other functionality, but there is the carboxylic acid functionality and the carboxylic acid functionality, that is basically C double bond O, and there is OH, right? And the rest is the R. So if that functionality is attached on the compound, so you will always use the suffix acid, right? So there is no question about this. There shouldn't be any confusion this. So carboxylic acid on the first and the highest, the most top priority. Then the acid chloride, then the aldehyde, nitrile, ketone, alcohol, amine, and halide. So what does it mean? So when we are moving towards the decreasing order or the priority of these functionality group, it means that the suffix will be of the highest priority functional group, and the other, which is on the lowest priority, so that will be added as a prefix, because prefix is treated for the substituents or substitutions, the minor functional group, and the suffix is basically to mention for the major functional group. Now that is your task, right? And that you have to submit. So there are the 3 compounds. These are just the same compounds which were given in your previous task, but at that time you were asked for identifying the functional group. Now we are just extending that you practice on the same compound, that now you have to write their IUPAC name. You will see, you will apply all these 4 rules, that you will identify the longest carbon chain, then you will look into the major functional group, then you will start numbering from the side where this is the nearer to the major functional group. The third one is that you will look into the substitution if there are any substitutions. So then you will number these, when you will mention their positions as a prefix, and you will name these compounds by just adding the YL with the substitutions. And if there is no substitution uh, except there is a major group, so then there is no substitution name required. So you just have to mention the position of the major group and you will just name that one. So just a hint that there is no example with the 2 substitutions at the moment. So this is somehow the simple task for you, so you can practice that one. But even then, if there is any question, any queries, and you are not clear about something, so you can just write to me and you can ask, or you can comment on the video lecture. So have a good day, just practice, it will make you master in it.